For the last 2 years, you have been told that artificial intelligence is a productivity tool, a chatbot, a parser, an assistant that drafts your emails, organizes your calendar, or summarizes long PDFs. But behind closed doors, a massive, quiet paradigm shift has just occurred. The global financial giants, Visa, MasterCard, Stripe, and the largest venture capital firms in Silicon Valley, have realized that the next major leap in economic growth will not come from humans using AI. It will come from letting AI use our money. We are transitioning from the Internet of Information to the Internet of Autonomous, Automated Capital. Up until this point, the entire global financial infrastructure was built around a singular, non-negotiable security assumption that a living, breathing human being must initiate, approve, and authorize every single transaction. Whether you scan your face, tap your physical card, or type in a 3-digit security code, the system requires human presence. But what happens when an AI agent needs to buy processing power? What happens when an autonomous software loop needs to purchase raw API access, hire another specialized AI model to write a script, or book a complex, multi-leg shipping route for a physical supply chain? If the agent has to pause, alert you, wait for you to wake up, check your phone, and manually approve a $12 purchase, the entire promise of machine speed efficiency collapses. The bottleneck of the modern economy is no longer computational speed. It is human latency. To solve this, the plumbing of the global financial system is being completely rebuilt. We are giving software agents the legal, physical, and structural capability to hold, spend, and clear credit card transactions autonomously. But this isn't just about convenience. This is the birth of machine-to-machine commerce, an entirely new asset class that is quietly transforming venture capital trends and shifting global wealth. Yet as these networks scale, they are running directly into a terrifying vulnerability. There is a specific underlying architectural flaw in traditional credit card rails that, if exploited, allows a minor software loop to drain a corporate line of credit in milliseconds. Before we look at how the institutions are trying to stop that, we have to understand exactly how a piece of software actually gets approved for a credit card in the first place. Let that sink in. Over 1/5 of all global trade is projected to run through systems where a human never clicks buy, never reads a review, and never holds a physical piece of plastic. It is software talking to software, negotiating, purchasing, and settling accounts in microseconds. If you think this is a futuristic concept, you are already behind. The plumbing is already live. To understand how we got here, we have to look at the massive engineering problem of putting a credit card inside an AI model. If you give an AI agent your traditional 16-digit credit card number, your expiration date, and your CVV, you have effectively handed a blank check to a system that operates on probabilistic logic. AI models are prone to hallucination, they are vulnerable to prompt injection attacks, and they do not understand the real-world value of a dollar unless they are strictly programmed to. If a bad actor hacks your AI agent, they don't just steal your data, they steal your entire credit line. To bypass this security nightmare, financial institutions are deploying a highly sophisticated security framework called tokenization architecture. When you authorize an AI agent to execute tasks for you, the bank does not issue a standard card. Instead, it generates a highly specialized, single-use programmable virtual card embedded with what developers call verifiable intent. This is where the finance meets the tech. Through programmable digital dollars, your bank can set ironclad, micro-level parameters directly into the financial token. For example, if you instruct an AI agent to build and launch a new web application with a strict budget of $500, the tokenized virtual card issued to that agent is programmatically locked. It is hard-coded to only authorize transactions from pre-approved merchant category codes, such as cloud hosting providers, domain registrars, and software APIs. If the agent attempts to buy a $600 subscription, the transaction is declined instantly at the network level. If a hacker attempts to redirect that token to purchase physical goods or transfer funds to an external account, the token instantly self-destructs. The credit card itself becomes an active firewall. This development is sparking an unprecedented wave of venture capital trends. Investors are realizing that the companies building the middleware, the secure translation layer between AI execution models and legacy banking rails, are sitting on an absolute goldmine. This is high-frequency automated finance, and it completely changes the unit economics of the internet. Think about how the current internet economy works. It is built entirely on subscriptions and flat rates. You pay $20 a month for this tool, $50 a month for that database, and $100 a month for another service. Why? Because human billing systems are designed for human predictability. We want one bill once a month. But AI agents do not work on a monthly schedule. They work in bursts of intense activity. An agent might need to run 10,000 database queries in 3 minutes to analyze a market trend, and then do absolutely nothing for the next 3 weeks. Under the old model, paying flat monthly fees for every single micro tool would cause software costs to skyrocket exponentially. Under the new agentic model, we are seeing the rise of hyper-fractional microtransactions. An AI agent can buy 3 cents worth of translation services from one model, pay half a cent to a validation model, and lease 2 seconds of GPU processing power from a decentralized cloud provider for a fraction of a millisecond. Traditional credit card networks, which charge a standard flat fee of 30 cents plus 2 to 3% per transaction, cannot survive in a world where transactions are worth fractions of a penny. The processing fee would be 10 times larger than the transaction itself. This is exactly why the legacy giants are racing to build a completely new high-yield settlement layer. They are utilizing advanced Layer 2 scaling networks, stablecoins, and next-generation API protocols to allow millions of instantaneous, near-zero-fee transactions to settle in real time. Whoever owns this new transactional infrastructure will essentially tax the entire automated economy of the future. To see exactly how this operates in the real world right now, let's look at a modern, automated enterprise scale study. Imagine a global logistics company managing thousands of tons of freight across the ocean. Historically, if an unexpected storm delayed a shipping vessel in the Pacific, a human logistics manager would have to manually review the delay, contact customs brokers, renegotiate spot freight pricing, issue new purchase orders, and manually authorize wire transfers to secure alternative cargo space. This process typically takes days, costing tens of thousands of dollars in compounding delays. With Agentic Commerce, the system operates completely untouched by human hands. The moment the weather data updates, an autonomous logistics agent detects the delay. Within milliseconds, it calculates the optimal alternative route, searches global freight databases for open cargo space, negotiates a contract with an automated broker, issues a programmatic virtual card payment to secure the container, and updates the custom declarations. A multi-$1,000 emergency operational pivot is resolved in under 4 seconds. No emails, no phone calls, no waiting for morning business hours, just code executing capital to solve real-world problems. While the economic potential of this technology is staggering, it introduces a level of systemic risk that the global financial sector has never had to navigate. In a human-centric economy, fraud and financial errors are rate-limited by human speed. If someone steals your credit card, there is a physical limit to how fast they can walk into stores or type card numbers into websites before your bank's fraud detection algorithms flag the unusual activity and freeze the account. Even in high-frequency trading, transactions occur within tightly controlled, closed-loop proprietary networks with massive institutional safety rails. But Agentic Commerce operates on the open web. If an AI agent is compromised, or if it simply encounters an unhandled exception, a software bug, in its decision-making loop, the consequences can be catastrophic. Consider a scenario where an automated purchasing agent gets stuck in an infinite loop due to a broken API endpoint. The agent believes it is successfully acquiring a critical software asset, but because of a server error on the merchant's end, it doesn't receive the confirmation signal. The agent does what it was programmed to do. It retries. But instead of retrying once every few minutes, it executes the retry loop at machine speed, tens of thousands of times per second. Within minutes, a minor software bug has generated millions of dollars in unauthorized transaction requests, completely exhausting a company's corporate line of credit, flooding the bank's processing network, and triggering a massive cascading liquidity crisis for the merchant whose payment gateway is suddenly overwhelmed by millions of requests. This is what researchers are calling an algorithmic run. It is the financial equivalent of a flash crash, occurring not in public stock markets, but private corporate bank accounts and regional banking networks. To survive this threat, the industry is forcing a massive shift toward what is known as zero-trust reconciliation models. Banks are no longer simply looking at whether a transaction has a valid card number and CVV. They are deploying real-world behavioral analysis tools that evaluate the intent of the machine making the purchase. Every AI agent utilizing these next-generation payment networks must constantly publish an encrypted, real-time ledger of its current operational state. Before a transaction is cleared, the bank's security layer inspects this ledger to verify that the purchase directly aligns with the agent's broader pre-authorized corporate mission. If the agent cannot mathematically prove why it is making a purchase, the payment is blocked before it ever hits the payment processing network. This development brings us back to the open loop we introduced at the beginning of this video. The silent, massive play that the top 1% and major institutions are making right now to protect themselves against this impending wave of tech volatility. As the traditional financial system becomes increasingly automated, volatile, and dependent on complex software loops, the risk of systemic software failures rises exponentially. To hedge against this, smart capital is not just betting blindly on the AI companies themselves. Instead, they are quietly acquiring ownership in the physical, real-world infrastructure that guarantees financial settlement no matter what happens to the software. They are investing heavily in secure custody solutions, highly specialized sovereign data centers, and advanced cryptographic clearing networks that exist completely independent of the public internet. They are buying the digital fortresses that house the ledgers, ensuring that even if the automated economy experiences a massive algorithmic shock, the physical records of wealth remain completely intact and untouchable. The future of wealth is no longer just about who owns the most capital. It is about who owns the gatekeeping infrastructure that allows capital to move. As we watch the line between technology and finance completely dissolve, the rules of leverage, investment, and wealth preservation are being rewritten in real time. The machines have officially been given the keys to the global economy. Your only option is to understand how the system is built, or find yourself locked out of it entirely. Welcome to the new ROI. If you want to survive the shift, hit subscribe. We'll see you in the next dossier.